All right, here we got 1.4 arithmetic operators for C++. And to start off with arithmetic operators, we have the first one here, which is just addition. Okay, and in order to use addition, we use the plus sign in our code. And you can see a couple examples here because we can do this many different ways. So you start off by seeing something new here on this first line. This is a unique way to just write the data type one time and then make multiple variables with that data type. Notice how they're separated by commas. I'm going to show you and explain that one a little bit more in the live code. And focus just on the arithmetic operators right here. So you can see I can use just two numbers if I want to, or 3 or 4. I can chain a bunch of plus signs down. I can add two variables together and then store it in a different variable, or I can do combinations. And even at the same time, I can add 3 variables together and assign it to A that's being declared at the same time. So these operators are really, really flexible and can be used in many different ways, okay? Now we see the same one with subtraction here, okay? Everything's pretty much the same, just subtraction symbol subbed in. Then we have multiplication, which is the star. That's shift 8. So if you look at the number 8 on your keyboard, you'll see the star. Then we have the division operator, which is just the slash. And then finally, we have the modulus, okay? Now, division and modulus confuse a lot of early students, okay? And the reason why is because of integer division. Now, you can see I made mine all here in ints. And the thing about ints is they don't store decimal values, right? They're just integers. So a 5, a 10, a -5, but not a -5.1, not a 12.1. So what happens when you do 5 by 4? Because if you do 5 divided by 4, you should get, what, 1.25, right? Because 4 goes into 5 and there's a little bit of excess. But when you do it as ints, because 5 divided by 4 is just ints, you just get 1. You get the whole number. You don't get any of the change. It just cuts it off. Well, if you had doubles, that would be much different. We would get the 1.25, okay? This introduces the modulus operator, okay? The modulus is just like division, but it's going to give us that excess value that we missed as a whole number. So 5 mod 4, we would say, well, the remainder to that would be 1, because 4 goes into 5 one whole time, and there's 1 left over, so it would be a 1. If it was 6 mod 4, the remainder would be 2. So in that case, this would equal 2 if it was 6 mod 4, okay? So keep that in mind, all right? If you need that change and you need to use ints, you can get that change with the modulus. If you can use doubles or you can use floats, and you can divide with those also and just get the decimal value, okay? But I see a lot of logical errors in programs when students forget about integer division. Okay, the next thing, and this is an easier concept, okay? You've been hearing this word a lot, operator, okay? And it's a special, a lot of times they're symbols, unless it's the size of operator. They're pieces of code that do things, right? Like an operator is going to add two things together. What is it going to add together? The operands, okay? Now, you don't hear me refer to them too much as operands. I think, saying 3 plus 4 identifies it just fine. But when you go look up C++ references, you're going to see these words and you need to know what they mean for those situations. So let's do a live code just to cover the few things that we went over just now. Okay, so let's do some examples of what we just learned, all right? I'm going to declare 3 variables on the same line. Okay, this is something new. And this is totally valid to do. I can do it with doubles also, so I can go E, F, and G. But the key to doing this successfully and doing it right is that all of these have to be the same data type. E, F, and G are all doubles. I cannot mix and match when trying to do this single line declaration initialization. Now here I just declarized, so let me give them some values. So we'll call that 5, call that 7, and we'll call that 11, all right? And then let's do some decimal versions too, which I don't feel like I showed in many of the examples. All right. And also in the examples in the PowerPoint, I showed you guys that you could use these in a lot of flexible places, but I can also do the math right here if I want and print it out at the same time I'm trying to add it. So let's do one with ints and one with doubles. And let's make sure this works. Let me give this a compile, give it a run, 12, 16.61. Everything looks good. Okay. So here, right, A and B are operands. The plus sign is an operator. Okay. All pretty straightforward. But the most important one we need to talk about is the division and the modulus. Okay. So let's change this and let's do B divided by A. And then here, let's do B mod A. Okay. Let's give this a compile, give it a run, and we can see the numbers 1 and 2 come out. Okay. So think about this for a second. B is 7, A is 5. 5 can go into 7 one whole time before it can't go in again, right? That's why we get a 1. We know the answer would really be 1 point something, okay? But this is integer division. We don't have decimals. It literally just gets cut off the end. Now the modulus keeps track of the remainder. And again, it can't give us the remainder as a decimal, right? So 5 goes in once, there's 2 left over. That's where we get the 2, okay? Very important. I see a lot of people make mistake with integer division, think they're gonna get a decimal, all right? Now let me delete this line. And let's do the division with doubles. So let's go F divided by E. Let's give it a compile, give it a run, and you get 1.4. So there it's totally fine. The modulus is really only important for integer types, okay? Now, notice how we didn't mix any types. We're gonna avoid mixing types in this video because I am gonna do another video probably in about 2 lessons about casting and how we can work with different types and make them play nice. All right, the next concept is going to be compound assignment. And the reason why we're going to do compound assignment is you're going to see that you're going to want to add to an existing variable or subtract, multiply, divide, modulus a lot. So much that we've developed an operator to simplify this process. So here you can see we have 3 values, 5, 10, and 0. And if I wanted to add, update y, I wanted to take y and add another number to it, but save it back in y, that's what would happen here. Now, I feel like I said what was kind of a mouthful. So let's put it this way. Y is 10, okay? And I want to add y with x, which is 5, but I want to store it back into y, all right? And this should also give you an idea that we look at this right side and then look at the left. So we go 10 plus 5 is 15. We store 15 in y now. So y is 15. It is no longer 10. We've updated its value, okay? So this whole line can be truncated, though, with the plus equals operator. It's where we add and assign. It is equivalent to this one up here, okay? It's the same exact thing as if I write y equals y plus x. It just actually honestly kind of looks better. With y plus equals x, I can sit there and go, oh, I want to add x to the value of y and save it in y, okay? So both of these, assuming they weren't run together, because now after this line, y would be 15, so this would make it 20. But both of these objectively do the same thing. And we can do it with subtracting and assigning. We can do it with multiplying and assigning, dividing and assigning, and then even the modulus and assigning. Okay, it works for all of them. All right, you're going to find that these are very, very handy, but you can get away with doing it this way also. Now, the next thing is precedence of arithmetic operators. It's very important to understand the order. Now, if you look up online the precedent of arithmetic operators, you're going to see probably a list with 20 different categories of operators. And by categories, I would say like these assignments here fall under a single category, okay? There's a lot of operators, down to even this scope operator, which we haven't talked about yet until we get to namespaces. But there's a lot. I'm focusing us in on what we've seen so far and then adding in these parentheses, okay? The best way to think about it is for math, for the purposes of doing math operators, it works just like PEMDAS, okay? Just like the order of operations you learned in school. So if I look at this 4 plus 3 times 2, it is not adding 4 and 3 to be 7 and then timesing 2 to be 14. It is going to the multiplication first. 3 times 2 is 6. 6 plus 4 is 10. So it works just like your math class. Okay, so multiplying and dividing and now modulus will be executed before addition and subtraction from left to right. Now, of course, what if we want certain things to be done earlier? That's where the parentheses come in. Okay, the parentheses can kind of give precedent to a certain operation. Because we put 4 plus 3 in parentheses, we will now add 4 and 3 to be 7 and then multiply by 2. Okay, now finally, I know we don't really think of the equal sign as an operator. We think of it as just assigning value, but it has precedence of when it's going to be looked at. And this is very important. The times equal operator is below all of these. So if I use that here, if I go b times equals 4 times 5, well, it's going to do the 4 times 5 first because that has higher precedence to be 20. And then take 20 and multiply it by b and store it back in b. So you're going to be very careful with these. I know we think that, maybe times equal would have a higher precedence than minus equals, but they're on the same level here. Okay, so be careful. They're underneath addition and subtraction. So let's do some live code to see what it looks like. So back to our code, let's work on those two things, right? We have that kind of compound assignment, and I want to show you a couple things. So A is equal to A plus B, right? So here we would take 5 plus 7, store it back into A to be 12, right? Let's print that out just to be sure. Okay, let's give it a save, give it a compile, give it a run, and we get 12. Okay, good, I know how to do math. Let's do it again though. Let's go A plus equals B, which now A is 12, right? That value for A has been updated. So we should have added another 5 to it to be 17. Okay, so I can't do math. 19. 12 plus 7 is 19. Sorry, I thought it was 7. B was 5 for a second. But everything is working. These are the same. Use them interchangeably. Okay. Now, the next thing we wanted to focus on was precedence, right? What gets done first? So let's jump down here and let's do a crazy long expression. Okay, let's go int. Let's just do, no, we're going to use G. How about just H? Okay, equals A plus B times C times B divided by 3 plus 2. I'm just making stuff up at this point. Let's put in some more multiplying divided by 3. I mean, this is probably so much stuff we're going to get back to 0. But let's see what happens. Let's print this out. Okay, so it wasn't. All right, we did a lot of multiplying in there to decrease that number, so these divisions didn't hurt it too much, but we got 667, okay? We can string a ton of stuff together, okay? And we can combine in variables, we can combine in just numbers, whatever we want, all right? But the order is just like math class. This was probably executed first, and then we looked from the left and right and multiplied with C, and then multiplied with B, and then divided by 3, but then we didn't do this addition because we needed to do 2 divided by 3 first, which would have just been 0 because 3 can't even go in a whole time, and it would have just been whatever this value was, which had to have been 667, okay? So be very, very careful with these. Generally, you don't want to string most of this together. You probably want to break it into many parts, but pay attention to the order of things. Okay, so I titled this one Complicated C++, and I did that because these are how do I say this? C++ is referred to as expert friendly. And because it's referred to that way, it can be very tough for beginners to feel comfortable. And part of that is because there's so many different ways to do so many different things. If you look up lists of just how to initialize a string, you might see like 5 or 6 different methods to get the same thing. So to beginners, that's difficult. It's like, well, which one do I use? Why do I use it, right? And so we try to focus in on the mainstream ones for beginners. But it can be important to see these other methods because when you go to Stack Overflow, when you go online and look at stuff, you're going to see them. People are using them, all right? And they have like these very niche circumstances where they're important, okay? So I'm going to show you to them, but I don't expect you to be able to use them perfectly right now. But hey, maybe you might like one of these, all right? So here we have awkward assignment. It's not actually called that. It's still just initialization, but look at its place, right? We made C equal to 2 right here, okay? And then we added that with 5, okay? So D must be 7 here, and C is now 2. So C was just declared before. It was initialized in line and then used as an operand in addition. That could be pretty complicated to a newbie. It's possible to do. You don't have to do it, but now you've seen it. The other is multiple assignment. This is actually pretty cool. I first learned about this in Python before I learned about it in C++, but we can take a 2 here and assign it to 3 different values just by going E equals F equals G equals 2. Because once we assign 2 to G, and we say, well, I want F to be equal to whatever G is, and so then that's a 2, and then I want E to be equal to whatever F is, and so then that's a 2. So this is kind of cool, and these will all be treated separately. If I change E, it won't change F in the future. They're not tied, okay? So keep that in mind. These are some unique things that you can do, all right? Now, let's do a little bit of live code with those funky assignments. So this should be our last thing, okay, is first looking at that awkward assignment. In order to use that awkward assignment, you have to at least have that variable declared because you cannot declare it in line. And then you should be able to use it just fine. So I can go 11 plus and say I is equal to 2 right here. And then let's print out J and make sure that everything is on the up and up here, okay? So if everything goes well, J should be a 13, if I know how to add. Boom, 13, okay? So we can do this kind of cool stuff here, all right? And then lastly, multiple assignments. So let's use M, M, N, and O. And let's say M is equal to N, which is equal to O, which is equal to 100. And then let's print them all out. So we'll print out M, and then I'm going to copy and paste these for the other ones. Whoa. Okay. Let's try that again. And then I'll just change these variables. Okay. So all of those should print out 100. And they do, okay? So I think this one is super cool. I've seen many situations where this is really, really helpful to do, okay? This one, I don't know a time where I would want to assign this. Like, why wouldn't I have just assigned it equal to 2 up here? It seems more like maybe at runtime this could be helpful. But if you're able to declare something ahead of time, you know you're going to need it. If you're doing it this way, you probably have an idea. You could do it on a separate line, just a line before. But this is where C++ gets difficult, right? Because you can do this, even if it may not be the best way to do it. And you can do things that are confusing, okay? So try to stay in those streamlined processes unless there is an actual reason that putting I equals 2 in the middle of an expression is more important or better than doing it just on the same line where you declared it. As always, it is time for a quick code, right? It's time to test those skills with a simple calculator. So and again, very simple calculator at this point. So you need to ask the user for 3 ints and store their values in 3 separate variables. And I want you to start making your program clean, like talk to the user, okay? You don't have to be polite to the user, but don't just have a program that has no prompt and you know that you're entering in numbers, okay? Start trying to tailor it to a user. They need to know, hey, enter in 3 ints. They cannot be decimals. They need to be integers, right? And then even be like, okay, you entered in these numbers. So it's kind of a more clean, polished program. The next thing is I want you to do is perform all 5 arithmetic operations with each input and let the user know what happened. So if they enter in a 5, a 6, and a 7, okay, then I want you to add all those numbers together and print it out and be like, I added your numbers and I got this. And then I multiplied your numbers and I got this. And then finally, do a weird expression like this, okay? I gave you a long one here that you can use that includes all of them. But, do something long. Practice that precedence of operators and mixing variables and numbers, okay? I would just recommend using this one and plugging in the numbers that the user gives you, okay? So that's your practice, and I'll see you guys next time.